Hey everyone, and welcome to another deep dive. Today we're going to be taking a closer look at SQLite, specifically how it keeps your data safe, even when things go wrong.
We're talking about the Acidity properties of transactions.
ACD properties.
Yeah, it sounds a little intimidating, I know, but trust me, this stuff is fascinating.
Okay, so why should we care about ACD properties? Besides avoiding a chemistry experiment gone wrong, obviously.
Because these properties are working behind the scenes every time you use an app, buy something online, or even just send a text message. They're the unsung heroes of data integrity, really.
Okay, I'm intrigued. So ACD is an acronym, right?
You got it. It stands for atomicity, consistency, isolation, and durability.
Like the 4 pillars of data security.
Exactly.
Okay, I'm ready to break it down. Start with atomicity. What's the deal with that one?
Atomicity basically guarantees that transactions are treated as one whole unit of work. Either all of it succeeds or none of it does.
No half measures.
Right. Imagine you're transferring money online. Atomicity ensures that the money is either taken out of your account, A&D put into the recipient's account, or the whole thing is reversed.
So no money disappearing into the digital void.
Yeah.
That's good to know. And how does this play out in the actual code of SQLite? The +2net article had some interesting examples.
Yeah. They had that one with the intentional error, where they try to update student grades, but they make a typo.
Oh, right. They try to update a table that doesn't exist.
Exactly. And because of atomicity, even that small error triggers a rollback of the entire transaction. It's like SQLite saying, nope, not going to let that slide.
That's pretty cool. Like a built-in safety net for our data.
Mm-hmm.
Okay, we've tackled atomicity. What about consistency? That sounds pretty important too.
Absolutely. If atomicity is about making sure transactions are complete, consistency is about making sure they follow the rules, that they make sense in the context of the database.
So it's like the rule book of the database world.
Precisely. Think about it like baking a cake. You can't just throw in a bunch of random ingredients and hope for the best. There's a recipe, a set of rules to follow.
Consistency is the head chef making sure our data doesn't end up a complete mess.
Exactly. In the +2net article, they actually have an example of this. Someone tries to enter a student's grade as 110, which obviously doesn't work because the maximum is 100.
Right, that would totally mess up the whole grading system.
And consistency is what prevents that from happening. It ensures that every transaction follows the database's predefined logic, keeping your data, well, consistent.
I'm starting to see how these ACD properties really work together to create a secure foundation for everything. Pretty impressive. Okay, what about isolation? I'm curious about how that one comes into play.
Isolation is all about giving each transaction its own space to operate. It makes sure they don't interfere with each other.
So it's like having separate work areas.
Yeah, like imagine trying to work on a shared document and everyone is editing at the same time.
Oh, I can see where that would cause problems.
Exactly. Isolation prevents those kinds of data collisions. It ensures that each transaction is executed as if it were the only one happening.
So each transaction is completely oblivious to what's happening with other transactions.
Until it's their turn, exactly. The +2net article illustrated this with those two transactions happening at the same time, remember. One was updating a student's grade, and the other was trying to read that same grade at the same time.
Oh, right, right. That sounds like a recipe for disaster.
It could be, but because of isolation, the second transaction only sees the final committed grade, not the one that's still being updated.
So it's like each transaction has its own little bubble.
Exactly. And they can't see what's happening in the other bubbles until the final version is ready.
Okay, that makes sense. So we've got atomicity to ensure transactions are complete, consistency to make sure they make sense, and isolation to keep everything in order and prevent conflicts.
You're getting it.
But what about the D in ACID? Durability. That one sounds pretty important too, especially in this digital age.
Oh, it's definitely important. And that's actually a perfect segue into part 2 of this deep dive.
You're killing me.
Stay tuned because next time we're diving into durability and how it protects your data even when things go really haywire.
And we're back. All right, so durability, it sounds pretty important, making sure our data can withstand, well, anything.
It's essential, really. Think about it. Systems crash, power goes out, sometimes the Wi-Fi just gives up on you.
Ugh, don't I know it. So how does durability help in those situations?
Durability basically means that once a transaction is committed, it's permanent, even if the system crashes right afterwards.
Oh, wow. So it's like if you're writing something, the computer crashes, it's still there when you reboot.
Exactly. And the cool thing is the +2net article actually demonstrates this. They have this whole scenario where they add a new student to the database, and then they simulate a system crash, like poof.
No way. They really went there. So even with a crash, the student's data is still there.
It's still there. Durability makes sure of that. It's like those changes are permanently written into the database.
Okay, that is reassuring. Like a safety deposit box for data. No matter what happens, your info is safe.
That's a great way to put it. Durability gives you that peace of mind knowing that your data is in good hands.
This is why I love deep dives like this. We're taking these technical concepts and making them, well, understandable.
It's like this whole hidden world working to keep our digital lives running smoothly. And all these ACD properties, they each play a crucial part.
Speaking of, we've covered all four now. Atomicity, consistency, isolation, and durability. Before we go any further, can you kind of sum up how they work together to keep our data safe?
They really are a team, each with their own job to do. Imagine them as guardians of your data, working together.
Okay, I like that. So atomicity makes sure transactions are complete, no loose ends.
Right, then you have consistency, making sure everything follows the rules.
And isolation, keeping those transactions separate so they don't mess each other up.
Exactly. And finally, durability. It makes sure that once those changes are made, they're permanent.
Wow. It's like the Justice League of databases, each with their own superpower.
Haha, that's one way to put it. But it's because of this system, this teamwork, that we can trust the data we use every single day. We don't even have to think about it.
That's a good thing. Imagine if we had to worry about every little thing we did online. Thankfully, ACD properties have got our backs. But how does all of this actually affect us? Like, in the real world?
Ah, that's a great question and a perfect way to transition into part 3 of this deep dive. We'll be back in a jiffy to talk about that.
Don't go anywhere. The most exciting part is coming up next. And we are back for the grand finale.
Okay, so we've covered all things ACD properties, but some of you might be thinking, so what? How does any of this affect me when I'm like online shopping or something?
It's a good question. Most of the time, you don't even realize these properties are working behind the scenes. But think back to those online banking glitches we talked about. ACD properties are the reason those are actually pretty rare. That's true. I can't remember the last time my online order just disappeared, thankfully. But I've definitely had those moments where a website freezes right when you hit confirm purchase. Makes you sweat a little.
Exactly. And that's when ACID properties are working overtime, making sure your money doesn't just vanish. They're the unsung heroes of a smooth and reliable digital life.
Okay, I'm convinced. ACD properties are essential. But they almost sound too perfect, like this unbreakable code. Are there ever times when you wouldn't want these properties to be so strict?
You're right, ACD properties are the gold standard, but yes, there are some specific situations where sticking to every single rule might actually slow things down.
Really? So it's a trade-off then? Like choosing between having things be super secure versus having them be super fast.
What? Yeah, exactly. Think about something like a huge online video game, millions of people interacting in real time. If every single action had to be totally isolated, imagine how much lag there would be.
Oh, that's true. So in those cases, developers would maybe relax some of the ACD rules to make sure things run smoothly.
Exactly. It always comes down to finding the right balance for the specific situation, weighing data integrity against things like speed and performance. But it's not about just abandoning ACD properties altogether. It's more about making informed choices and really understanding all the factors involved.
That makes sense. So it's not a one-size-fits-all approach. It's about finding the right fit. This has been seriously eye-opening. I definitely have a whole new level of respect for databases now.
It's more complex than people realize. But hopefully, now when you're online doing your thing, you'll have a little voice in the back of your head whispering, ACID properties, that's what's making this work.
I know I will.
Yeah.
A huge thanks to you for this deep dive, for demystifying ACD properties, and for showing us how vital they are to our digital lives.
My pleasure. Always happy to geek out about databases.
And to all of you listening, thank you for joining us on this deep dive into SQLite and ACD properties. We hope you learned something new and interesting today. Until next time, stay curious.